So we'll start today with these 3 warm-up questions. Taking the derivative of each. Don't forget about the chain rule. I'll press pause and you give them a go. Over these. A few of you needed some reminders. That's okay. It's been a couple weeks. That's why we're doing the warm-ups. Derivative of sine is cosine. But remember, one layer at a time when you're doing the Tootsie Roll Pop rule. So derivative of sine is cosine. Leave the inside alone while you're working with the wrapper. Then move to the inside. Derivative of 3x squared would be 6x. And that's okay to leave like that. It would probably look better if you put the 6x in front. But those are the same thing. We said a minute ago that the natural log rule is 1 over the argument times the derivative of the argument. And so a few of you are still writing it separate, which is fine. And some of you have switched to just sticking the derivative over the original. And then lastly, dy dx. Power rule, it's just kind of a nested power rule thing. So the 4 comes down front. We'll decrease the power by 3. Right, that's the outer wrapper, so we don't want to mess with the inside stuff yet. And then chain rule is multiplied by the derivative of the inside, so that would be 6x. And it would be perfectly fine to leave that as your answer. But if you're looking on a multiple choice test, obviously they would clean that up a little bit. Okay. Now, today we're going to go backwards. So what if I gave you the answer and said that dy dx is equal to 5 over 5x minus 7? So if the derivative is 5 over 5x minus 7, do you know how to drive forward well enough to recognize what's going on that you could put that one in reverse? What would the original function be so that it has that for a derivative? Nedge, you said it?
It would be ln of 5x minus 7.
Natural log of 5x minus 7. And with natural log, we end up putting the argument in absolute value bars to make sure that it's positive. But yeah, so it's because that would be 1 over the argument times the derivative of the argument. Well, let's do one more of those. This thinking backwards thing here. What if the derivative was 6 times 2x plus 5 to the 5th times 2? I sort of wrote it to hopefully make the going backwards thing easier. Can you figure out what the antiderivative would be, what y would be, so that it would have this derivative? Aaron, what do you think it is?
2x plus 5 to the power 6 times 2x.
Not times 2x, because that 2 would come from the chain rule of the inside.
Yeah. Okay.
So that 2 is a result of the chain rule. So yeah, the 6 and the 5 is where that comes from, but that 2 is the result of the chain rule. It's trickier going backwards. What we're going to learn today is a tool to help us go backwards. Some of you are not going to use that tool. Well, you'll have to use it some of the time, but it's to handle problems like these. And so some of you on ones that are relatively simple, these qualify as relatively simple, right? Relative being the key word there. Some of you are not going to use the method we do today. You're going to look at it and be like, oh, I can kind of think backwards and figure that out. And that's okay. If you can do that, that's fine. But what we're going to do today is look at a tool that will help us sort of sort through that a little more step by step with a clearer method to work with.